Hello and welcome to this video on trigonometric integrals. We're finding the integral of secant cubed of theta d theta. To find this integral, we're going to use a combination of things. We get to use the integration by parts formula and we get to use a trigonometric identity. The integration by parts formula we use is the one for indefinite integrals. We have the integral of u dv equals uv minus the integral of v du. As for the trigonometric identity we're going to use, we have the following one. We have that tangent squared of theta plus 1 equals secant squared of theta, or same thing, tangent squared of theta equals secant squared of theta minus 1. Now, we're going to rewrite the integral of secant cubed of theta d theta as the integral of secant of theta times the secant squared of theta d theta. So we're going to choose u as secant of theta and dv as secant squared of theta d theta. Then v is equal to the integral of secant squared of theta d theta, which is tangent, and du is equal to secant of theta times tangent of theta d theta. Let's move this a little bit to the left. Okay. With all this information, what we have is that the integral of u dv is the integral of secant times secant squared of theta d theta, and that's u times v. So secant of theta times tangent of theta minus the integral of v du. And we have tangent of theta multiplied by secant of theta and then by tangent of theta d theta. Okay. Now, what we're going to do is we're going to write secant of theta, tangent of theta minus the integral of tangent squared of theta, secant of theta d theta, because tangent times tangent is tangent squared of theta times secant of theta. And then we're going to use the fact that tangent squared of theta is secant of theta squared minus 1 to get that the integral we're looking for is the secant of theta times the tangent of theta. And here I forgot to write a minus instead of an equal. Minus the integral of secant squared times secant, that's secant cubed of theta. Then minus times minus gives us plus the integral of secant of theta d theta. So the integral we're looking for is something minus that same integral plus something else. We can solve for the integral we're looking for to get that twice the integral of secant cubed of theta d theta is secant of theta times tangent of theta plus the integral of secant of theta d theta. And the integral of secant of theta d theta is one of those integrals we want to remember by heart. This is the ln of the absolute value of tangent of theta plus secant of theta, and then plus constant c. So the integral we're looking for, secant cubed of theta d theta, turns out to be half of the right-hand side. So we have half of secant of theta times tangent of theta plus the half of the ln of tangent of theta plus secant of theta in absolute value plus half of the constant, but that's just another constant we can call the same way c. Okay, so we have used integration by parts and trigonometry to find this integral. Sometimes we have to do that in order to find integrals of trigonometric functions. If you have any questions, let me know, write a comment, and I will be happy to help. Thank you for watching. Bye-bye.